30, 45.
Bursted.
How long ago was 4 hours? But over stuff like your backpacks and two backpacks last semester.
Bursted? I don't feel like bursted's a
And
word.
then you stuff that
Bursted's
thing
not a word.
and you still have more stuff.
Okay,
It's not a word.
let's talk about the plan.
The plan.
The plan. We're going to be doing section 5.5 today. 5.5 is the last section of chapter 5. We've got a test coming up.
That's terrible.
Yeah, it is. So here's the deal. My current plan is on Friday, we're going to do a quiz, practice test kind of thing, something like that, with some kind of review after it. I don't think we'll have enough review and enough time to get enough feedback from that quiz, practice test, whatever you want to call it, to like be ready to take the test on Monday. And my experience is Monday is not a great day to give tests because nobody takes it together and all that kind of stuff. So probably what we'll do, let's go ahead and say what we'll do is the test will be on Wednesday, like a week from today. There'll be more review on Monday, and we'll probably start taking a little nibble into the the next chapter or whatever. Okay, so that we don't lose the whole day over that. But anyway, so there will be some kind of quiz that I do want you to do well on Friday. Okay, I haven't actually decided yet. It might be on paper rather than online for a variety of reasons. Just because some of this stuff, I want you to go write out equations, and that's a little bit hard to do on, up to a Google form. All right, which means we only have this last day of it to go. And this last day of it, they go a little bit nuts. A lot of the sections in chapter 5 were like 4 pages long. There really wasn't that much going on in some of those sections. And then this last one, section 5.5, they go a little nuts. There's just lots and lots of stuff in here. But it turns out none of what's in section 5.5 is something you have to memorize. They are tools that you use, but they'll always be given to you. For example, for now, they are all in the front of your book, too. All the formulas that we're going to be learning about today are also in that front page of the book, which at the very least you would have a copy of. If not, it was an open book kind of thing. I have not yet decided whether the quiz is like an open book or open note kind of thing, or whatever. I'll send you a message when I figure that all out. I thought I'd write it first and see how it's going. So anyway, the point is, even if it were closed book and closed notes, let's say it was all that, I would still give you the sheet from the front of the book that has all these formulas we're going to be learning today, as well as all this other stuff like the unit circle and all that kind of stuff. You always have access to that. There is no point in trying to memorize the formulas that we're having today. They are tools that you use to solve certain kind of problems. And it's pretty straightforward to see how that's going to work when you take a look at, like, on page 384. The first couple of formulas that we're learning are the so-called double angle formulas. Where, like, you want to know what the sign of, I think the symbol they were using was 2u. So, like, you've got some angle. Let's just say, let's just do something simple. How about 90 degrees? Well, 90 degrees is twice 45 degrees. And now, admittedly, the sine of 90 is not a hard one to do, but like there are other ones that they'll do that you would need it. And the sine of 2u, according to the double angle formula, is just 2 times the sine of u times the cosine of u. So like in this case, it would be, since u is apparently 45, it's 2 times the sine of 45 times the cosine of 45. And you multiply all that out and you'll get, well, what is it? Square root of 2 over 2 times square root of 2 over 2. So that is 2 times 2 over 2 times 2, which is equal to 1. So the double angle formulas that you have there at the beginning are tools for figuring out if you've got some angle, but half that much is something you know, like you know what the sine of 45 is and the cosine of 45 is, you can solve it that way. So that's the kind of thing that they're doing here. Now, most of the time they're not working with numbers like 90 and 45. It's more like example 1. Let's actually do example 1 real quick. Again, no one's expecting you to memorize these double angle formulas. You're expected to be able to find them in the front of the book and use them as a tool to solve a problem. like for example, this one that is 2 times the cosine of x plus the sine of 2x plus the sine of 2x equals 0, right? Yeah, okay. So notice in there we've got that sine of 2x term. There probably are ways we could rearrange this thing using inverse trig functions and so on. But we're in the double angle formula. We've got a double angle here. We know, I'll just copy the first part of the equation over here. The sine of 2 times some angle is just this formula right here. 2 sine x cosine x. Well, now I see that I have I can do some factoring here. I could use my big skills they learned in Algebra 1 and Algebra 2 and say, well look, this one's got a 2 in it, and this one's got a 2 in it, this one's got a cosine x in it, this one's got a cosine x. We can use our factoring and see that this is 1 plus sine of x. And that's such a handy thing because we know this pattern. If I've got 2 things multiplied by each other and the product is 0, that is a thing. That is a thing that we've seen over and over again. We now know that means either this side's equal to 0 or this side's equal to 0. So either 2 times the cosine of x equals 0, which means the cosine of x is equal to 0, because we just divided the 2 over here, didn't do us anything. Cosine of x equals 0 happens at x equals pi over 2 and 3 pi over 2. Right? Those are both places where cosine is equal to 0. Or this side's equal to 0. 1 plus sine x equals 0. Sine x equals negative 1. And that only happens at 3 pi over 2, I think so. Which actually means we duplicated one of those things. Is that what they got in the book? Yeah. Yep. Now your book, again, is going to be doing that business of, and there's repeating solutions. You know, like every 2 pi plus that's going to happen again. I don't care about that. Okay. We're not going to, your book might get all excited if you look to the back of the book on a similar problem. It might say like x equals pi over 2 plus 2n pi or something like that. What they mean is just put a 0, a 1, a 2 here. So like it could be this plus 0, this plus 2 pi, this plus 4 pi. I don't care about that. Don't worry about that. Find the basic solutions. That's all I care. So these double angle formulas that again you have at the page in a blue box with yellow highlighting on page 384, but probably far more conveniently, right there in the front of the book, you've got the double angle formulas. There's also these on page 386, the so-called power reducing formulas. The power reducing formulas are tools for getting rid of a term that looks like sine squared of x or cosine squared of x. And the power reducing formulas are shown there on page 386. And like for example, the sine one is 1 minus the cosine of 2x over 2. Is that right? Yeah. So if you have some formula that had a sine squared in it, well, here's the deal. If I had a formula with sine squared in it, I'd first look to see if the Pythagorean theorem would help. Remember that sine squared plus cosine squared equals 1. That probably is as likely or more likely to be what helps. But if it isn't, if that's not what's getting the job done, maybe this would. So like, I don't even know if they give a great example of it. I love the one that they have there in the book on example 4. But you know, if you had some kind of formula that was, I don't know, sine squared x plus the cosine of x equals 0 or something. Okay, there's probably something we could do in here using the Pythagorean theorem and see what we could do with this. But another possibility would be to expand this with this and then see where we can go from there. They're tools. When the washing machine is broken, I get out my box of tools But I don't know in advance whether I'm going to need wrenches, screwdrivers, what size of screwdriver I'm going to need. You got to just work with your tools. And when I just look in the back and I'm like, oh, there's a bunch of screws to take off here, I don't actually know which screwdriver is going to fit until I actually try it, right? In the same way, these are just tools. What'd you say there? The right way to... Well, no, you just put things on there. No, the first screwdriver you put on there, oh, crud, it's too big. It's a little stupid notch, right? Or it's this little small screwdriver. Because I'm an idiot, I might try like the eyeglass screwdriver first. Oh, that's too small, right? No, I wouldn't really do that, but whatever. First of all, I'd call the guy to fix the washing machine. Dryers are no big deal. Washers are no big deal. All right. So they give us these power-reducing formulas. Again, they're in the front of the book. We don't have to memorize them. Or like these half-angle formulas that are on page 387. A whole mess of tools where you can find sines and cosines of some weird numbers. So for example, if you needed the sine of 15 degrees, the sine of 15 degrees is not on your unit circle at the front of the book, and like if we weren't using calculators or something like that, how would you get the sine of 15 degrees? Well, 15 degrees is the same thing as 30 degrees divided by 2, and 30 degrees is one of the angles we know. So if we treated 30 degrees, so this is our u or whatever in here, then we could use that formula on page 387. We know cosine of u because use 30, cosine of 30 is it's in the table in the front of the book. It's on the unit circle. And then we'd be off to the races. And it'd be messy because it's got square roots and stuff in it, but it can be done. .388 is where things get to be even more of a mess, though. These are a pair of rules, the product to sum formulas and the sum to product formulas. Where if you've got something like, if you look at the top of page 388, if you've got something kind of ugly, like the sine of u times the cosine of v. So you got two different angles here. Or an x and a y or whatever. Sometimes, just like sometimes the right tool is this drill, and sometimes the right tool is this hammer, sometimes those are tools you don't usually mess up. No. Sometimes the right thing to do is to try breaking this up. You've got a product, and you change it to a sum using those rules at the top of the page. And sometimes it's the other way around. It just depends on what you need to do. And all you can do with this is practice. All you can do is try solving problems with these. And I know you guys hate that. But that's why we have to do a homework assignment about it. That is a little messy. We're going to do the homework assignment in the more traditional way this time with a biggish one that you turn in next time we meet. This assignment comes from page 390. And what I want you to do is numbers 1 through 6 all. And I want you to do 9 through 19 odd. And there's some strangeness in the instructions of 9 through 19. What you're supposed to do is use Desmos. I'll show you an example of one of these in just a minute. But what you're going to do is you're going to use Desmos to find approximate answers. Then solve. Solve like on paper, algebraically. We'll do an example of those in just a minute here. Yeah.
Is that our income assignment?
Yeah. No, we're doing the whole thing. This whole thing we're doing in the traditional way.
Oh.
Okay. All right. So because I want you to get some good exercise with this strategy of how you solve these problems, and then I want you to do 21 and 23. And I didn't just pick these problems at random or something like that. There are reasons, like on the tests from downtown and stuff like that, I know you need to know these guys. 27 to 37 odd. And my notes here, I say these problems involve Desmos too. It says something about your graphing calculator. Obviously, you do that on Desmos. And page 49. Sorry, problem 49. If I remember right, those ones, the second set of them there, what it wants you to do with Desmos, if I'm remembering right, is you have two different expressions, and part of what you do is you're checking to see if the two expressions mean the same thing. So like, let's say one side is the cosine of 2u, and the other side is 2 sine u cosine u. You make the two graphs. If they're right on top of each other, you've done it right. If they're not on top of each other, then you've got a problem.
Should they?
Yeah, well, I believe that's what's going on here. Let me look at that one real quick. So 21 is an example there.
Let's just do Friday.
No, wait, hold on, 27.
Yes.
Yes, this is due on Friday.
Gotcha.
Yeah.
So like on 27, it says use a double angle formula to rewrite that expression, and then use the graph that you. So like on 20, I'll do 28 since you guys had 27. So on 28, which is not one you guys do, it's what 14 sine u cosine x. Okay, sine x cosine x. Well, remember. 2 sine x cosine x equals sine of 2x. This is one of your rules that you had today. And you're pretty damn close to that. I mean, this right here is 7 times 2 times sine x cosine x. So if we just substitute this out, it's now 7 times the sine of 2x. Make a graph of this, make a graph of this. If they're right on top of each other, you've done this right. If they're not right on top of each other, you've done this wrong. Make sense?
Yeah.
All right.
Wait, would you not put the cosine x for the
What?
second one either?
No, because this, see, okay, so I took this part over here. 2 sine x cosine x is equal to 2 sine 2x.
Oh,
So I made that substitution right here.
so, okay.
Yeah. And they're giving you pretty heavy-handed advice there on that one, where they're telling you it's about the double angle formula in instructions. I mean, you don't have to tear through the whole table in the front of the book looking for the right one.
Watch it.
All right, so does everybody have, like, they've written this down?
Yes.
All right, then let me show you an example of what they mean for, like, those first set of problems that are 90 through 19I.
Wait.
Wait.
Oh, all right, everybody got it written down, or taking a picture of, or whatever? Got it? All right, it's not going anywhere. I mean, once it's, I'm not wasting it, it's just up here. All right, so let's take a look. Those are 9 through 19 odd that they're doing that. So let me look at like number 10 real quick here. Number 10 in the problems right there. Ah, wait, 10's different. Let's do 12. It says, in the instructions for problem 12, it says, use a graphing utility like Desmos to approximate the solutions of this equation in that range. And the equation on number 12 is the sine of 2x plus the cosine of x. Alright, so I'm going to go over here. So I'm going to plot like f of x, I don't even know if I need that. Let's try the sine of 2x plus the cosine of x. Ooh, it's an ugly function, I like it. Alright. So that's what that thing looks like, and we're trying to figure out where that thing is equal to 0 in the range from 0 to 2 pi. And, well, it crosses here, and here, and here, and here. So, now, Desmos is pretty damn smart. It's really giving you the answers here, right? Your answers are going to be 2 pi, pi over 2, 7 pi over 6, 3 pi over 2, and 11 pi over 6. Okay, we now know those are the right answers. But then it says, and find it algebraically. So let's see that expression, see if we can figure that one out. So you're going to give me that graph. Because I love getting those things. And then you're going to say, okay, the expression we had was the sine of 2x plus the cosine of x equals 0. Okay, but we know what this thing is equal to. It's 2 sine x cosine x. Alright, plus the cosine of x equals 0. Alright, well we can do some factoring here. We got cosine of x in both of these parts. So it's the cosine of x times 2 sine x plus 1 equals 0, and it's our favorite trick. We have a product of two things that together make 0. That means either cosine of x equals 0, or 2 sine x plus 1 equals 0, none of which seems right. Let me just take a look real quick here. Hold on, did I do something wrong with this one? Number 12. Okay, we'll be good. Okay. Doesn't feel right. Okay, hold on. Alright, where is cosine of x equal to 0 on that range? Cosine of x is equal to 0 at x equals pi over 2 and 3 pi over 2. Okay, that sounds right so far. And this one over here, that means 2 sine x equals minus 1. That means sine x equals negative 1/2. So we need places where the sine of x is equal to negative 1/2. Guess I'm going to go look at the front of my book here. And I'm going to look over here and I see that that happens at, let's see, the sine is negative 1/2, happens at 7 pi over 6 and 11 pi over 6. X equals 7 pi over 6 and 11 pi over 6. Hey, wait a minute. Pi over 2, 7 pi over 6, 3 pi over 2, and 11 pi over 6. I briefly lost faith, but it was right.
That's crazy.
Woo! That's what they want you to do on those problems like 9 through 19 or whatever. Find yourself this. Decimals will even give you the answers. By gosh, those are the ones you're looking for right there. Your calculator may or may not have. And then actually do it algebraically like this. All this can work is by practice. All you can do to learn to fix washing machines is just keep trying to fix a washing machine.
No, it's not. It's good. Why is everyone so disrespectful?
Ryan, you're my favorite.
Thank you.
Anyway,
I really don't think that's how it works.
that's why plumbers have to do like that. I don't plumbers don't fix washing
How
machines.
many
The last side of the room is just a pit of hate.
A pit of hate.
Except for Jay.
That's true.
Anyway, that's why a plumber has to go through like a
Back row.
6-year
Y'all
apprenticeship,
good?
right? All you can do to know how to fix plumbing problems is practice. All right? You're an apprentice trig people right now. Go work on your trig problems for a while before I make the exit ticket available. All right.
It's like
Meanwhile, Natalie I know has a problem.
Well, then you gotta use one of your other tools.
All right. What you got? And I have to tell you
Not a problem.
And I just like.
It's so right.
Oh, it's
Just gonna have a vision bunch of get it back to you. You can have extension on this.
We'll just go.
Oh, this is really
What sign is over to? Where'd you find that? Is it in the front?
No, like right behind.
I agree.
Oh, perfect.
you do like the two review on the cosine 2 of that.
No, there isn't. But you know what? Pi over 12 is pi over 3 minus pi over 4. 1/12 is a wonderful number because it happens to work out 1/3 minus 1/4. So like pi over 3 minus pi over 4 equals pi over 12. And remember, these were the angle difference formulas. You could replace pi over 12 with
I don't like
and then in that section, you have
Hey, but my mom makes that.
you know, this is a this
well,
I'm sure you'll still play that like it.
yeah, I don't like apple buns or like wherever it comes from. I just don't like it.
Yeah.
But I'm pretty sure.
Right. Pi over 12 is what you don't know.
So,
Yep. That's where you're going. Yep. It's just this.
There's another type of pie right here. I just get confused for it.
So then, once you have that, you know, or like, you is pi over 3 and your e is pi over 4, then it'll all.
No, think banana pudding.
Yes.
Well, if 1
Banana
third minus
pudding's
1 fourth equals 112, would we multiply both sides by pi do the same thing? So that pi over 3 minus pi over 4 equals pi over 12?
Or yeah.
Okay. 67. What are they doing? Are they verifying this one? Or what are they about to ask for? Okay, so they want you to manipulate this thing until they're obviously the same. Okay, so you have gotten.
I was saying it was this one, but I saw the exponents.
1 minus sine squared y will be cosine squared y.
Oh man, now I gotta break it down.
So you've got cosine squared x times cosine squared y minus sine squared x sine squared y equals this.
So we did drop your answer.
Well, yeah, give yourself a little bit of shot at that, but I'm sure that it has something. So you're basically just getting into the two sides are clearly the same. You're getting real close here, aren't you? I'm not sure. Okay, take it a few more steps. The fact that you got it far will be okay. Okay? Take it another step or two and see if you get it anywhere. Okay? I mean, I'm not going to wait. Here's the deal. What's the real thing? The real thing going on in this assignment is knowing how to do these rules. And you did them. And then the other thing that was about this question was knowing what verifying that. And you're clearly what verifying, right? The fact that you may have the assignment error is an indication of the next row. Here's the deal. My suspicion is somewhere along the way between the counts. My suspicion is somewhere along the way on the assignment error. Or what is You know what I'm saying? Is that what the assignment's really about? Right, you're doing the right thing. If you get a little bit of the same thing I'm doing, okay? Remember, I'm not going to test. But I mean, like, then you clearly have demonstrated, you know what verify means, and you clearly demonstrate that you're doing rules for expansion. That's what the assignment's really about. Okay? So you're all right. Oh, I should have turned off the camera. Now I have video evidence of the classroom being filled with hate. Is that what the expression was?